Hello everyone, Michael Jones here from Michael Jones Custom Knives. Welcome back to my forge. In today's video, I'll walk you through my latest build. Sitting next to me here is a PID temperature controlled tempering and heat treating oven that I just completed. Now this oven runs off of liquid propane and it has a thermocouple K-type sensor to control the temperature and an electric gas valve on-off valve to control the flow of propane. So in today's video, I'll walk you through how I built this and I'll point out some of its features and capabilities, and I'll also demonstrate how it operates. I hope you enjoy this video. I hope that you'll find this something useful, maybe you can use in your own forge or workshop. So if you enjoy this video, please come back and check out my channel for future videos, and as always, please subscribe. To get started, I went and purchased a used 100-pound propane tank. In the photo, I've already removed the valve from the top of the tank. There are plenty of videos online to show you how to safely do this, but the most important thing to remember is you need to make sure the tank has been purged of any propane or leftover gas. The second thing is, for safety, I filled the tank completely full of water to purge any remaining gas that might have been inside. This is very important because if you cut into a tank that hasn't been purged, it could explode or catch on fire. So if you choose to do this, proceed at your own risk and make sure you follow all safety precautions before you work on any type of compressed gas or propane tank cylinder. As you can see in the video, the bottom of the cylinder is pretty rusted out where the stand is, and it's also uneven. So I've decided to cut this off smooth so later I can make a stand with rollers so I can move this around when the project is completed. Next, I start working on the pilot lights for the oven. This is going to be a 2-burner oven, so I have to create 2 pilot lights. Here I'm drilling out a 1/16 inch hole in a stainless steel 3/8 plug, which will be the orifice for the pilot light. testing the pilot lights using a stainless steel needle valve to control the flow of the propane. Once it's installed on the oven, I can fine-tune the pilot light based on what it needs for the burners. I'm reusing the Venturi burners that I built for my first forge before I converted over to forced air. I have 2 of these burners, and these are my own custom design. If you'd like to see how these were put together, I might do a video on these someday in the future. Let me know in the comments if you'd like to see more about these Venturi burners. I didn't video it, but I've already lined the inside and bottom of the tank with 2-inch thick K-wool. Now I'm drawing some vertical lines to mark points where I'm going to drill holes to insert pins and weld them in place, so those will be anchor points for the refractory when I pour it. Once the K-wool and the pins are in place, now it's time to drill the holes for the burners. The first burner is going to be about 1 inch above where the refractory bottom of the chamber will be, and then the second burner will be about 18 inches above that one. These brackets I'm making will be the mounts for the burners. There'll be 2 of these welded onto the side of the tank. To line up the burner down the center of the burn tube, I decided to cut a plug out of wood so that I could insert it and perfectly align the pipe of the burner down the center of the burn tube. The inside of the plug is cut to the same outside diameter as the pipe on the burner, and the outside diameter of the plug is the same as the inside diameter as the burn tube. I simply screwed the plug on the end, inserted it, used my magnets to line up the mount, and then tack welded everything in place and checked the fit. This way I got a perfect alignment of the flare inside of the burn tube once it was all welded up. Here I've got the gas solenoid mounted and all of the valves and tubing necessary to hook up the propane to the pilot lights and to the individual burners. I'll explain how all this works toward the end of the video. Here's the finished PID controlled oven. I forgot to film the installation of the control box and the installation of the PID itself and all the associated wiring. But here in a moment, I'll go over all the features and demonstrate how to operate this oven. To start off with, I'll explain how the liquid propane gas is set up for this oven. So you see all these valves, these hoses, and everything feeding everywhere. I'll try to explain how this thing works. Here on this side is the main gas line connection. You hook up your gas line to a regulator and set the pressure coming in. I usually set it between 15 to 20 pounds. You have a main shutoff here for all the gas. Once you turn this valve on, that allows gas to flow into this manifold setup here. It hits the manifold and comes out this T and feeds these two lines to the pilots. I have shut off so I can control each pilot individually, and then how large the flame is on the pilot is controlled with the needle valve on each of the pilots, which feed into the burner tube, which allows the burners to be ignited. Now, the way this is set up, the pilots are always burning as long as you have gas flowing from your tank and this valve is turned on. Here you have the solenoid, 110, 120 volt solenoid that's in the off position always when it's not getting current. So the way this works is your thermocouple and your PID are hooked together. The PID has a set point for what temperature you're shooting for. And then the thermocouple reads the temperature and feeds it to the controller. If the temperature is below the set point, then it causes the PID controller to kick on the circuit, which feeds electricity to this solenoid, which allows gas to flow. Coming out of this solenoid, when that happens, I hit another T, and I've got lines running to each individual burner with shutoff valves. So I can control each pilot and each burner individually with these shutoff valves. So if I just want to run the top burner or run the bottom burner, I can run those individually if I want to. And once the burners kick on, and the temperature rises and hits the set point with it plus or minus a few degrees, then the thermocouple reads that temperature. The PID controller knows to cut the flow of electricity off to the solenoid, which shuts the gas off. And that way, whatever your set point temperature is, the temperature is rising up and down around that set point as the burners turn off and on. That's basically how the setup is for the burners and for the pilot lights, and how this solenoid to control the gas flow works. Okay, I'm going to demonstrate how you light the pilot lights on this oven. Right now I've got the main gas hooked up. I've got the regulator set to 15 psi, and I've got the main gas valve on, and I've turned the gas line on leading to this top pilot light, but I have the needle valve is off right now. So the way you light this is you just get you a lighter here and get a flame going, put it next to the opening, and gently open the pilot light valve until it starts, and then adjust the flame. Hopefully you can see that burning on camera. Here's a close-up of the pilot light burning. This is the top one. You do the same operation for the bottom, and again, you can control how much flame is coming out with this needle valve. And that should be about good right there. Okay, here's what the inside of the control box looks like and all of the wiring. I'm not going to go into a lot of detail here of how all this is wired. I will try to provide a wiring diagram at the end of the video that you can reference. But basically what we have here inside the box, we have an on-off switch, we have a bypass switch, we have the PID controller itself, we have a heat sink, and a solid state relay. And then this yellow adapter or plug here on the side is a connector for the K-type thermocouple. I mounted that so that I could, on the outside, plug and unplug and change out thermocouples without having to redo the wiring. I used an old extension cord that I had that had a bad end on it, so I cut that off and used it for the power cord. And then I had another bad power cord on a grinder that I had, that I cut the cord off and used it for the lead running out and heading to the solenoid to cut the gas on and off. Again, very basic setup. I will again try to explain how this works in a diagram at the end of the video. All right, here I'll try to explain the operation of the PID, turning the power off and on, and what the unit does when it powers up. So basically on the panel here, you have an on-off switch that controls the main power, and we have a bypass switch. So when you turn the power on, the PID is going to power up, and it's going to go through a self-diagnostic. Once that's done, it'll start receiving temperature readings from the thermocouple through the input here, and that'll display on the top row here. And the second row here, it'll have what the set point value is, and by default it'll come up and retain the last set point that you had. So I think this one was set at around 1006, 1009 degrees Fahrenheit, something like that. So when I turn this on and it finishes its self diagnostics and boots up and starts receiving the temperature input from the thermocouple, it's going to kick that valve on, because obviously this is not at 1000 degrees right now. So it's going to kick that on and run the burners until it reaches that set point, and then shut the valve off, and then it'll start cycling off and on to maintain that temperature. What the bypass does is, regardless of whatever I have set for the set point, if I click the bypass on, it will burn or have the burners run continuously regardless of whatever the set point is. So if you wanted to temporarily bring the oven up to a higher temperature without adjusting your set point, you could do that by turning on the bypass. Or if you needed to run this for some reason, at full out, it would run continuously until either you shut it off or you ran out of propane. So what I'm going to do here is I'm going to turn it on. It'll go through its self-diagnostic and boot up, and then you're going to hear a loud click, and that'll be the solenoid turning on as if it was supplying gas to the burners. So here I'll turn the unit on. It's going through its setup or self-diagnostic. That loud click was the solenoid kicking on because it's currently 92.9 degrees on the inside of the chamber. The set point is set at 1009 degrees. So it would sit there and run until eventually this temperature matched the set point, and then it would start cycling off and on to maintain that temperature. If you want to change the set point to raise or lower the temperature, you simply have these buttons right here, an up button and a down button. If you press the up button, you can see the temperature changing, and then that sets it to a new set point value. And then you hit the set button, and now it's set. And if you want to lower it, again, you do the same thing. You change it to a different set point, and then you hit set. And now it's set to a new set point. That's basically how the unit works. All right, I'm getting ready to get the oven going here. I've got the gas line hooked up, and I've got the air purged out of the gas lines. I got the pilots lit, and I've got the set point set to 1600 degrees. So as soon as I turn the power on, it'll go through its self-diagnostic, and the burners will kick in, and it'll start heating up to operating temperature. Here we go. Now the burners are both kicked in. As you can see, it's starting to go up on temperature. A little noisy, but here you can see the burners are lit. They're both firing. All right, we're just about to break 1000 degrees. Now we're over 1000 degrees and we're still climbing. All right, we just hit 1500 degrees. We got just a little ways further to go and we'll be at our set point of 1600. I still have steam coming out of the hole from the thermocouple. It's still burning off some of the moisture that's left over from the refractory. So that may be contributing to why it's taking a little bit longer for it to heat up, because the steam, the water is cooling off the thermocouple, but it is coming up to temperature. Okay, we've crossed 1550 degrees. We're now at 1552, still climbing. That's hot enough to heat treat 1084 and 15N20 Damascus. I've got the set point for 1600 to go over a little higher than 1550. Give you some extra time for when you pull it out of the chamber and get it into the quench tank. So we're still need just a little bit more. Probably another 5-10 minutes, we'll be there. Now we're cycling off and on. It'll maintain the temperature around 1600 degrees. And as the refractory continues to heat up inside, it'll get more and more stable as it goes. Since this was the first burn, there's still moisture coming out. So I think an adjustment of the thermocouple will probably help this out quite a bit. So it's maintaining right around 1600 degrees now. And it'll keep cycling off and on until I turn it off or change the set point. As promised, here's the wiring diagram for the tempering and heat treating oven. I'd like to give a shout out to Tyrell Knife Works for the inspiration on how to wire this. He has a good video out there where he put in a PID controlled forge, and he has a nice diagram that was the inspiration for how I wired up mine. So I'll put a link in the description to that video if you want to go check it out. This concludes the build of this tempering and heat treating oven. I hope you enjoyed the video. It was a lot of fun making this, and I'll be putting this to good use soon in my forge. I plan on making some longer knives and even some additional swords in the near future. This is a good tool to have around. As always, I hope you come back and check out my channel for future videos, and please subscribe.